Ideal Industries continues to set the standard for innovation, performance, and quality with our full line of test tools for the working electrician. Ideal's latest innovation is a line of open-closed circuit tracers. The new SureTest circuit tracers provide electricians with performance, ease of use, and safety features to reduce the frustrating and time-consuming task of tracing electrical circuits. This program illustrates how the technology and innovative design of these SureTest tracers makes the task of circuit tracing easier, more accurate, and safer than ever before. The Ideal SureTest circuit tracer line consists of 3 kits: the 61954, 61956, and 61958. All 3 kits are open-closed circuit tracers, and all 3 kits utilize the same TR958 transmitter and TL958 test lead kit. The 61954 comes with an RC954 receiver, while the other 2 kits come with the higher-end RC958 receiver. And the 61958 kit also comes with an inductive clamp and battery pack in a larger hard case. The transmitter works from 0 to 600 volts AC or DC and can be hooked up to a circuit via an outlet adapter, test leads, or alligator clips. It uses standard banana-type plugs for inputs and has an isolated battery compartment that holds 4 AA batteries. To power on the transmitter, depress the power button. The left LED illuminates as notification that the unit is now transmitting a signal. The transmitter monitors the voltage across the input terminals. If more than 30 volts AC or DC is present, the center LED lights to alert you. The right LED is the low battery indicator. This LED begins to flash when the batteries are within 10% of depletion, then switches to a steady on state when the batteries need to be replaced. Remember to power off the unit after tracing to extend battery life. A complete set of test leads is supplied for use with the transmitter. These can be used for plugging into outlets or attaching to bare wires and grounding points. There is also a 25-foot lead adapter to connect to remote return paths. There are 2 receivers to choose from, an RC954 and an RC958. First, let's go through the common features. Both receivers have an isolated battery compartment that holds 3 AA batteries. They also have 2 antennas, one in the nose for finding circuit breakers and one in the backside of the nose for tracing. The bottom button is used to power the unit on and off. This button is to select the mode of sensitivity. By depressing the top left button, the percentage of battery life remaining is displayed, while the top right speaker button toggles the audible on and off. The differences between the 2 receivers lies in the features of the displays. The RC954 receiver has a bright LED display that indicates a 0 to 99 signal strength and incorporates a peak detector bar graph for instantaneous changes in signal strength. A decimal point lights if the batteries are low or if the audible is turned off. When the sensitivity mode button is depressed, the display will indicate the mode that the unit is switched into, where 1 is maximum sensitivity and the default mode. 2 is medium sensitivity, 3 is trace mode, and 4 is the least sensitive, breaker mode. The RC958 receiver has a super bright OLED or organic LED display. This display also indicates a 0 to 99 signal strength and incorporates a peak detector bar graph for instantaneous changes in signal. It also has a rotating display, so that regardless of the receiver's position, the numeric display stays upright. It also displays the battery status symbol, percent battery life remaining, audible on-off state, and sensitivity mode. There are 4 sensitivity modes to choose from: Search High, which is the default mode, Search Low, Wire Tracing, and Breaker mode. Another nice feature of this RC958 model is the energized state of the circuit. The transmitter continuously monitors the power status and sends a signal to the receiver. So if the circuit is powered, the lightning bolt is lit on both the receiver and transmitter. Once the receiver finds the breaker and the circuit is opened, the transmitter recognizes the loss of power and sends a positive confirmation to the RC958 receiver that the correct breaker was identified and tripped. The 61958 kit also includes the inductive clamp with its battery pack. The clamp has a 1-inch jaw opening for getting around conductors in tight locations, and the battery pack holds 8 easy-to-replace C-cell batteries for providing plenty of tracing power. The magnetic strap included allows for easy mounting onto a panel or conduit. To use, just plug the clamp into the battery pack and clamp onto the wire to transmit a signal. All 3 of these kits identify breakers and fuses, trace circuits, pinpoint opens and shorts behind walls, in ceilings, and even underground. They can trace AC or DC powered circuits up to 600 volts, as well as de-energized circuits. GFCI protected circuits and circuits with sensitive electronic equipment on them can also be traced. These tracers use AA batteries to provide for 4 times the tracing power of traditional 9-volt models. The ideal SureTest circuit tracers also provide a high level of safety protection, as they are rated for use in Cat 3 commercial industrial environments. It's important to understand the basic theory of circuit tracer operation. The transmitter generates a pulsed electromagnetic field onto the circuit. The receiver detects the relative strength of this field when placed in the proper orientation to the wires being traced or breakers being identified. As the signal becomes stronger, the receiver's numeric value and variable pitch and tone increase. In general, tracing should start at the maximum setting. If the signal saturates the receiver to display 99 continuously, then reduce the sensitivity mode. There are 2 concepts you need to understand to maximize the signal in the circuit and ease the task of tracing. The first concept is the effect that an open versus a closed circuit has on the signal. Whether a circuit is open or closed greatly affects the strength of the electromagnetic field. In an open circuit, there is no current flow, so the strength of the magnetic field produced is much weaker. But in an energized closed circuit, current flows to produce a much stronger electromagnetic field. This allows the receiver to detect the signal from a much greater distance from the circuit being traced. So when possible, set up a closed circuit for tracing. The second concept is utilizing a remote return path. When current flows, it creates an electromagnetic field counterclockwise to the direction of the current flow. As current flows out on a hot conductor and returns in the opposite direction on a neutral conductor, it creates opposing magnetic fields. So if these 2 wires are close together, the magnetic fields tend to cancel each other out, which diminishes the receiver's ability to detect the signal. To avoid this canceling effect, one lead of the transmitter should be connected to the conductor to be traced, while the second lead should be connected to a remote return path in order to prevent this signal canceling effect. The simplest method is to use the 25-foot test lead to connect to a neutral or ground from another circuit, or connect to a ground source, such as a water pipe or ground rod. SureTest receivers offer you 4 modes of sensitivity. In general, you should always start at the maximum